This video will show you how to calculate a single point equilibrium in the graphical mode of Thermo-Calc. The calculation is based on example number 1 of the examples listed on our website. However, this video will show you how to build the calculation so that you can customize it. If you want to learn how to use the examples as they are on our website, view the video How to Use Examples. To begin, open Thermo-Calc in the graphical mode. The easiest way to create a single point equilibrium is to use the template. Simply click on the Single Point Equilibrium button and all the nodes will appear in the project pane. You can also add the nodes manually by right-clicking on the bottom node, hovering over Create New Activity, and adding them one at a time. Once you have your nodes, you must configure each one. Start by selecting the System Definer, where we'll select our database and elements. Click on the Database drop-down menu and select the FE Demo database. If you're using an older version of Thermo-Calc, use the pturn database, and if you're doing your own calculation, select the database you need. Next, I'll select the elements iron and carbon. The system is now defined, so click on the equilibrium calculator to set the conditions. Because we're making a single point equilibrium calculation for an iron-carbon alloy at 1000 Kelvin, we need to set temperature, pressure, system size, and composition. Based on the example, the temperature is 1000 Kelvin. The pressure is 101,325 Pascal, and the system size is 1 mole. For the composition, we only need to set one element because the system size has been defined, making the other element dependent. Therefore, when we set carbon, iron will adjust automatically. We'll set carbon to 0.1 weight%. Remember, you can change these amounts if you're working on your own calculation. You can also change the units for temperature, pressure, and so on, and you can change the composition unit. We also need to select our calculation type, so select Single Point Equilibrium. Our calculation is now configured, so select Perform Tree at the bottom center of the program. Once the calculation is complete, a table will appear in the results pane. The top section of the table gives you information about the system, such as the mass, temperature, and total Gibbs energy. Below that, you can see the stable phases. In this example, there are 2, BCC and graphite. Here you can see how much of each element you have in each phase. If you click on the Composition drop-down menu, you can select Constitution, which will show you the models of the phase. Notice that you must change this for each phase. You can go back and change the configurations at any time to run a new calculation. You can also add additional equilibrium calculators and table renderers if you want to create additional calculations and compare the results. Each calculation will receive a tab in the results pane. You can export the contents of the table into a text file or spreadsheet by right-clicking anywhere on the table and selecting Save As. You can save the entire project by clicking File, Save Project As. We hope you find this example useful. We're constantly working to create new examples, so check back regularly for new files at www.thermocalc.com.